Hello friends, how are you? Okay, I hope all are fine. In previous video, I have explained acids. In this video, we will talk about bases. Bases are oxides or hydroxides of metals which taste bitter. It means how can you recognize bases? By the formula, if you have OH in formula, it will consider as base like calcium hydroxide, CaOH whole twice. So it means it is basic in nature. CaO, calcium oxide, which common name is quick lime. It is also basic. Oxides and hydroxides are termed as bases which have OH ion, or we can say which ionize OH ion in aqueous solution. We term them bases. Here you can see bases have bitter taste, soapy feel and react with acid to form salt. Later on we will discuss about salts, how acids and base react. Here we can see examples where bases are present, just like antacids, soap, lime water. What is the chemical formula of lime water? Slacked lime, CaOH whole twice. Toothpaste and glass cleaner. Glass cleaner contain ammonium hydroxide, NH4OH, which is also a base. Which base is used as a window cleaner? Ammonium hydroxide. Now here is a term alkalis. Friends, we have bases two types. One which are soluble in water and another one which are insoluble in water. The bases which are soluble in water are called alkalis, like sodium hydroxide, potassium hydroxide, ammonium hydroxide, barium hydroxide. These all are alkalis and these are soluble in water. But we have some hydroxide which are insoluble in water, such as copper hydroxide, copper oxide, which are insoluble in water or partially soluble. Calcium hydroxide, slacked lime is also partially soluble. Magnesium hydroxide, aluminum hydroxide, these are partially soluble. So we can't say them alkalis. So we can say all alkalis are bases, but all bases are not alkalis. I hope it is clear. All alkalis are bases, but all bases are not alkalis. It means कि जितने भी बेस हैं वो सब alkalis नहीं होते, क्योंकि सारे बेसिस पानी में soluble नहीं है. जो soluble होंगे उन्हीं पोर्शन को हम क्या बोलेंगे? alkalis. Then on the basis of strength we divide bases strong base and weak bases. Strong bases which 100% ionize OH ion in their solution, while weak bases which partially ionize in their solution. See here, depending on strength, bases are classified strong and weak. Sodium hydroxide, potassium hydroxide. Sodium hydroxide and potassium hydroxides. These all are strong bases, while weak bases include magnesium hydroxide, aluminium hydroxide and copper hydroxides. These are quite mild bases. Mild means weak bases. Now properties of bases are they are bitter to taste, slippery to touch and neutralize acid to form salt and water. These all about bases. Now here is one point also related to acid or base. When we talk about acids, we have to give a term basicity. Means we have to calculate basicity of acids and acidity of bases. Clear? How many hydrogen ionized by acids? We termed it its basicity. For example, sulfuric acid, H2SO4. We know it is a strong acid. it ionize two hydrogen which it have, so its basicity is 2. While we can see H3PO2, phosphorus acid, in which we see there are 3 hydrogen, but it ionize only 1 hydrogen. So its basicity is 1. Clear? Similarly, we termed bases which hydrogen ionize OH ion, we called it acidity. Suppose aluminium hydroxide which have 3 OH ions and it ionize all the 3 OH ion in solution. So we say that its acidity is 3. Aluminium hydroxide have acidity 3. What about calcium hydroxide? I mean quicklime, CaO, yes, slag lime, CaOH whole twice. What is acidity of slag lime? Yes, 2, because it has 2 OH ion and it completely ionized OH ion. Clear? Now start with acid base indicators. Indicators are those chemical substances which change their color when we put in acid and bases. We term them indicators because they recognize whether the substance is acidic or basic. Similarly, there are acid-base indicators and olfactory indicators. Olfactory indicators means which give different smell in acid and bases. So firstly we will discuss acid base indicators. The firstly we divide acid base indicator in two groups: synthetic indicators and natural indicators. Natural indicators are those indicators which we get naturally. For example, litmus, turmeric, China rose, red cabbage, these all are natural indicators. The first, litmus. Litmus is litmus is the most commonly used indicator. Sometimes questions arise, the most commonly used indicator is, then it is litmus. We get it from lichen which belongs to Thallophyta group. It is used in the form of solution. What is the original color of litmus? Its original color is purple. And it have two types litmus paper, red litmus paper and blue litmus paper. In acid, red litmus paper give no change. It means its color is red in acids. So we can say litmus paper color changes from blue to red in acids and in bases red to blue. You can remember this from B for base, B for blue. The final color will be blue in base. It means color changes from red to blue. Then turmeric. Turmeric is the another natural indicator which have yellow original color. When we have acids, then turmeric color changes to yellow only. So we can say no change in color. But when we apply base on it, its color changes to reddish brown or red. Similar example you have seen in your daily life. When you got stain in your shirt, then after washing it with soaps and detergents, color changes to reddish brown. It means turmeric is an indicator and soaps and detergents have bases. Next one is red cabbage. Red cabbage original color is purple. When we put acid in it, its color changes to red, and in base color changes to green. Friends, you can remember this by this point that mostly acids color are red, magenta, pink, while bases have color blue and green. Now we move to synthetic indicators. Here is table regarding indicators. You can take a screenshot of this so that you can remember or learn it. Clear? Now we move further with synthetic indicators. Indicators which are prepared artificially are called synthetic indicators. Examples: phenolphthalein, methyl orange. Phenolphthalein is colorless indicators. Commonly if we use phenolphthalein in lab, we see it's colorless. When we put in acids, no color change. But in bases, it show changes color in pink. Clear? So we can recognize which indicator we are using if basis turns to pink. Phenolphthalein. Original color of methyl orange, the second one synthetic indicator is orange. Methyl orange color changes to red in acids and yellow in base. Clear? See here table is also. You can take screenshot of it also. Neutralization. When acid react with base, this reaction is called neutralization and the product formed are salt and water. You can see here example. Sodium hydroxide, which is a base, react with acid hydrochloric acid. Then firstly you have to remove the product water. H from acid, OH from base. Now what has left? Sodium and chlorine. So it will combine to form sodium chloride. Friends, you always got confused कि always salt is sodium chloride. No. Any salt which include acid and bases, it form that type of salt. For example, sodium hydroxide react with sulfuric acid. So we get sodium sulfate, which is also salt. We get salt and water after neutralization reaction. Salts can be phosphate, nitrates, halides, it means sodium chloride, sodium bromide, fluorides, nitrates, all these phosphates, carbonates, all these are salts. Neutralization reaction is also an example of double displacement reaction and precipitation reaction and exothermic reaction because heat is evolved in this reaction and the product are formed salt and water. Friends, in next video we will discuss about application of neutralization reaction and salts. Okay, bye bye, take care.